Welcome to 20 Fingers 2 Brains. In this video, we are going to discuss what is the structure of JWT, how JWT token gets generated by the server on successful user authentication, how to send JWT in request header on subsequent request to the server, and how server verifies JWT signature and authorizes the user. Now, before watching this video, I would request you to watch JWT Authorization Made Easy video following the link at the top right. That video is prequel to this video, and in that video we have described how to use JWT authorization and how it solves the problem of authorization in depth. Now let's start with JWT structure. This is the typical JWT, and most of the JWT would look like this. The JWT token consists of three parts, each being base64 URL encoded and concatenated using a period. The middle part, which is pink in color, forms the payload of the token. The payload contains the metadata or the data about the token. The upper red color part is the header of the token. The header consists of the information of the algorithm which is used to sign this token and also what type of token is this. The bottom is the signature of the token, which makes this token a signed token. The signature is calculated using header, payload, and a secret which is kept at the server. So this is the structure of JWT. Now there would be two questions in your mind. What is base64 URL encoding? So base64 URL encoding is URL safe base64 encoding, and in base64 encoding, sets of 8 bits characters are converted to set of 6 bits characters. The second question in your mind would be, now this is the encoded JWT token, and we don't know from what JSON object this encoded token is created. So you want to know the details or the values of the JSON objects. So you want to basically decode this encoded JWT token, and that feature is provided by jwt.io website. So if you go to this website and scroll down, there would be a section named debugger, and on the encoded side you can paste your token, and on the decoded side the website would decode your token into JSON objects. So I've already pasted my token here, and we'll see how each part is decoded on the right hand side. So the first part is the header, and the header is decoded to JSON object having two key value pairs. So the first key is the algorithm, and the value of algorithm key is HS256. So we are using HMAC SHA-256 to sign the token, and the second key is type of token, and in our case it's JWT. Now this header JSON object is base64 URL encoded to form the first part of our token. Now let's go to the second part, that is payload. Now payload is the data of the token, and you can see the data consists of the username, email, and EXP. So EXP stands for expiry, and it is set to a date time after which this token would be invalid. And after that, the user has to authenticate again to the application and regenerate the token. And it is always advisable to have expiry on your token so that you generate your tokens on a regular interval. There are two more recommendations when you create your payload for the token. The first recommendation is you should have least amount of information required in the payload, because if you have large number of information in the payload, that would increase the size of the payload and in turn would increase the size of the token, and which can cause performance issues while transmitting it across the wire. The second recommendation is you should not store the sensitive information in the payload. That is because this token is encoded, not encrypted. And if a malicious user get hold of this token, he can very easily base64 decode it to get your sensitive information. That is the reason you should not include sensitive information in the payload. Then this payload is base64 URL encoded, and it's appended to the header and concatenated with the period. So this two parts forms the unsigned token without signature. The third part is the signature itself, and the signature is calculated by passing concatenation of base 64 URL encoded header, the period, and base 64 URL encoded payload, and then the secret. So this secret is stored at the server side and it is not shared. This three things are passed to the hashing function, and the hashing function would give us the result. That is what the signature is. And then the signature is again base 64 encoded and then appended to header and payload with a period, and then it forms a signed token. Now you would notice one thing: as the signature is computed from header, payload, and secret, if you make changes to any one of these, that would impact the signature. For example, if I try to manipulate the secret, I'll append some characters. You can see the signature is getting changed. Okay, and this is very important information in validating the token. We'll discuss this later. Now you would notice like payload is okay, that information would be required by the application. Why we need header and why we need algorithm details in the header. Now these header information wherein we specify algorithm to sign the token is utilized by server to validate the signature. We will see how the server utilizes this to validate the signature on the token. So this is the overall structure of the token, JWT token. And now let's go back to our slides and see this process again. So we have a JSON object on the left hand side, which is the header, and a JSON object on the right hand side, which forms our payload. Both of these objects are base 64 URL encoded to form individual, you can say, output of base 64 URL encode. These two output then concatenated with period to form unsigned token, a token without a signature. Then this unsigned token is passed to a signing algorithm or hashing function. This hashing function, using the shared key, generates a signature which is then converted to base 64 URL encode concatenated with unsigned token to make a signed token. So this is the overall process of generating a signed token. Now once the token is generated by the system and it is given back to the browser, the next question comes how I send back this JWT to the server for authorizing the user on the subsequent request. So you have to send this JWT as a HTTP header. So what is HTTP header? So HTTP headers are name value pairs, and it is a way by which client and server share data across request and response. An example of HTTP header is content type. So you set the content type to JSON or XML or a plain text. On a similar note, we are going to use a HTTP header name authorization, and its value is going to be the JWT token prefixed with bearer and a space. So basically you have to set a HTTP header authorization colon bearer text space and then the JWT token and send to the server. Now your JWT is sent to the server. The next question is how the server is going to validate the signature or validate the token. Now let's assume the header.payload.signature is our encoded token. So what server will do is the server will first decode the header and gets its JSON format. From the JSON format, it will get the algorithm detail. From the algorithm detail, it will get to know like this algorithm is used to create the signature or sign the token. So now you know like why we need algorithm details in the header. So once the algorithm details is known by the server, it will again base 64 encode the header. It will again base 64 encode the payload. Since server has the secret, it will calculate the signature again. Okay, and then it will compare it to the signature on the token. If both these signature matches, then the token is valid and user is authorized. If not, then user won't be authorized to access the application. So this is how the server validates the token. Now suppose a malicious user or a hacker got hold of your token and he updates the payload to have admin rights, and then he tries to basically send the token. Now since the signature is computed from header, payload and a shared secret, if hacker modifies the payload and as he doesn't have the secret which the server has, the hacker cannot compute the signature. Or if he computes the signature, he can do it by his shared key, not by the shared secret or the secret key at the server side. So the server will calculate the signature at its own end and then compare it with the signature at the token, and it would know like payload is being changed and hence the signature is different, and then the server would know like, okay, the malicious user has already updated the payload and the signatures are not matching, and thus this is not a valid, or you can say this is not a valid user and will not be allowed to access the application. So this behavior of generating a signature from header, payload and the secret helps us to validate the token at the server side. So this is all about how to generate the token, how the token gets generated, what is its structure, how it is passed to the server, and how a server validates the token at the server side. In the next video, we will implement the JWT token authorization in ASP.NET Web API application. That's all for this video. I hope you like this video. Thank you, friends.